Welcome to the first session on surface area and volume. And in the first section, as given in your CBSE book, it is about surface area and volume. We'll be taking in combine of them because though in book it's separately given as surface area and separately as volume, here we take as surface area of a surface area and volume of a combination of solids. See, I could have given all the formula here and then continue with the questions, but I prefer as and when we get the shapes in the question, we can keep on noting down the formula for finding out the respective surface area or the volume of the given solid shape, because they will all be combination of shapes now. Okay, let us take up the first question. I need to write down the question and then make the figure. An iron pillar has some part in the form of a right circular cylinder and remaining in the form of right circular cone. The radius of the base of each of cone and cylinder is 8 centimeter. The cylindrical part is 240 centimeter high. And the conical part is 36 centimeter high. Find the weight of 1 cubic centimeter. Find the weight of, I think I made a mistake there. Find the weight of the pillar if 1 cubic centimeter of iron weighs 7.8 grams is the conversion rate given. Now, as per the question, we need to draw a figure. I'm drawing a cylinder here, and on the top we'll draw the cone. Don't mind if I'm overlapping that writing part because I didn't think of making that go that high. This will be the height of the cone. This will be, I need to use some other color maybe. This will be the height of the cylinder. Because see, an iron pillar has some part in the form of right circular cone, cylinder, and the remaining as right circular cone. The radius of the base of each of cone and the cylinder is 8 centimeter. So if I need to write down, this will be 8 centimeter, even this is 8 centimeter. What else? The cylindrical part is 240 centimeter high. this is 240 centimeter high, and the conical part is 36 centimeter high. We have to find the weight of the pillar. To find the weight of the pillar, obviously we'll be calculating the total volume of this figure, the solid, which includes this cone and this cylinder. So to begin with, we are taking up I'll write this as R1. This is radius, this is H1 maybe for the cylinder, though let us see if we need it or not, because let me write the cone to be H2 and the radius of the cone we can take as R2. So what is the volume of the cone? Herein comes the first formula. Volume of the cone is given by 1/3 pi r square h. I was assuming this r we will denote by r2, so it is r2 square. H also we have denoted it as h2, so that makes it 1/3 into pi. I'm not solving them because later on we have to add it with the cylinder and then I can take common. So r was given to be 8, that makes it 64, and height is 36. Let it be as it is for the time being. Now we will add the volume of this cylinder. I'm not writing right circular cylinder, and it's simply I'm writing cylinder. What is the volume of a cylinder? It is pi r square h. So it's pi r, here we are denoting with r1, so r square. H we are denoting as h1, so that makes it pi r square and h, so it is pi into 64 into 240. This is also in cubic centimeter. Now we need to add them. To do so, I'll write 1/3 pi 64 into 36 plus pi into 64 into 240. That makes I can take 64 pi common, and that's leaving me with, this is 12, so it is 12 plus 240. I now replace it as 64 into 22/7 into 240. If we solve, 240 plus 12, that makes it 252. I rectify that, 252, and we solve this, I get I think this is getting cancelled as 36. Now this is in cubic centimeter. To get find the weight of the pillar, we have to convert this, multiplying it with 7.8, because it's one cubic centimeter is 7.8 grams. So we will multiply 64 into 22 into 36 with 7.8 grams. In that case, if I do this, I am getting 395366.4 grams. And to convert that into kilo, because the answer we will better write it in kilo, this many gram doesn't make sense writing, so the answer will somewhat be here. I'm writing it is 395 point, rounding it off makes it 0.4 kg. That is the total weight of this given pillar. Let me now move on to another question. This is though also a combination of a cone and a cylinder. I quickly write down this question. A circular tent is cylindrical up to a height, I'm using the short form, of 3 meter and conical above it. This is also again a combination of cylinder and cone. If the diameter of the base is 105 meter and the slant height of the conical part is 53 meter, find the total canvas used in making the tent. Oh, that is fitting in? I don't think so. Let me write it below. The tent. Let us draw the figure first. Is it a tent? I'll draw it a little flatter than the previous one. This is the cylindrical portion and I draw the cone above. The circular tent is cylindrical up to the height of 3 meter. That means this height is 3 meter. The diameter of the base is 105. That means this whole length, this one is 105 meter. The slant height is 53. This height is given to be 53 meter. Find the total canvas used in making this tent. To do so, we will have to use the curved surface areas because the tent will be, the canvas will be used here, here and this part. So we will be using, the total canvas used will be curved surface area of the cylinder plus the curved surface area of the cone. So what is the curved surface area of a cylinder? It is given by 2 pi RH. And the curved surface area of the cone is pi RL, and this L stands for the slant height. So it is 2 into 22 by 7 and the radius will be 105 by 2. That makes it 52.5 into height is 3 meter plus 22 by 7. The radius will be the same as 52.5 into L, that is 53. We can take this 22 by 7 into 52.5. That makes it 6 plus 53. That's giving me 59. So it is 22 by 7 into 52.5 into 59. If you calculate this, will give us an answer of 9,735 meters square. This many square meter of canvas will be required to make this tent of the shape which combines a cylinder as well as a tent. I hope you got that, you followed it well. Thank you.